presentation of one of our partners. My name is Hauke Hendricks, I'm the head of sales at Hoppe, and I'd like to welcome you to our booth for this very nice presentation of a good friend of mine, Bastian. Now, the idea is you all know Hoppe for good sensors and data. You have very good sensors and data, but Hoppe does not provide end-to-end solutions. So what you're going to do with that? Our perspective is always that take the best in class, best sensors, best data, best information from Hoppe, and then you need a partner for decision support. Today with me, Bastian Ginke, many years in Interschalt and Navis, and he will show you a little bit about the value of measured data. Thank you.
Thank you very much, Hauke. Now, taking over the microphone, I have to explain you how we take over the data. So today, I would like to introduce you a little bit into our solution, BlueTracker One. This is a performance analysis system where different data sources are coming together. We think for a holistic picture of your fleet, you need several data sources to combine. Many things you can measure in a high frequency, but there are others which are simply being reported. Things like the LCV, captain's name, so information which is giving a context, which is important to analysis. They come from other data sources as well. Weather provider information is a third-party interface, an example, AS data, all those things can be put on top. Today I would like to show you a little bit on what we do with the high-frequent measured data and how do they help to increase the insights in fleet performance. So one example is, of course, the accurate real-time tracking. So if you look at this picture here behind me, you can see a vessel report which has been positioned very accurately at the terminal where it is actually located. This report did not contain a position, but we have measured data which we can use to bring it together with the report, and we can correct the position of the report to its exact position based on the measured data. So this kind of insight is being provided by data which are collected from companies like Hoppe. If we look at another specific example looking into fuel performance, new report data, an example, are always averaged over time. And sometimes it's even worse because people are not providing the average kilowatt hours, or the average kilowatt of the shaft power, and also calculate the kilowatt hours, but they provide just the spot. At the moment, they're looking at the shaft power meter. So in that example here, it would be 15,000 instead of 13,000, which is actually the average which we're expecting. With method data, you get the full insight, and you can really see the detail and how the engine power has been developed, and these things can then be detected. So, in order to provide visualization, we see two different strategies at our customers. Some of them are looking into substitution. So they say, if we have available data which we can measure, we don't need to provide them via manual reports. We can substitute certain data points, and we can get a little bit easier for the crew to send reports, and we can get work offloaded from the crew because we substituted with sensors. Others are looking for combination because they want to cross-check manual data versus method data, because they want to prove if the information are correct or not. So here in this example, you can see a little clear warning. So there has been less fuel measured than actually reported, which also reduces your fuel. But you can see a worse efficiency of the SFOC. So these kinds of things are then being identified, and reported data always has less accuracy than the high frequent ones. I have another very nice visual example to show it to you. So in my next picture, you basically see two examples of the voyage tracking. Here I've used the speed as a very simple and easy to understand example. And in the above picture, it is based on manual noon reports. So you can see only very few dots throughout the voyage because every day we just receive one value. And it looks like the vessel is all the time green, so the KPI is always fine. But if we look into the measured data, we can see that this is not really the truth. So here we have the high resolution, the high frequency of accurate data, and it shows you that at a certain point in time, we have been outside the range. So the KPI is alerting you that something went wrong. This insight you would not get if you just have manual reported data once a day. So this is really an insight which is being generated by high frequency data. However, I want to mention as well that depending on the analysis, a level of aggregation might be required. So we are not always working with the high resolution of the data. Sometimes we need to aggregate them. It's totally fine if you zoom into a certain spot and want to analyze a specific problem on your engine within a, let's say, 2, 3, 4 hours time slot, maybe even over a day. It might be interesting to look into high frequency data and really see the every collected value. But if we look at hull performance, an example, where we analyze data over years, we have to aggregate that data to a certain level. That does not mean that we use the value of the high frequency, it just means we put an aggregation level on top. In the picture behind me, you can see how we deal with that in terms of visualization. So depending on the time range selected, we either show an aggregated high value, or we show you all the details which you can get from the measured data when you zoom in. And that's basically the high frequency graph which is popping up when you zoom in. That shall basically give you a little overview on how high frequency data are being used and what additional insights you can get. Some of these use cases and some others you can of course also see at our booth. So we're happy to see you there as well. We are on 434 on the other side of that. Thank you very much. Thanks all.